Ever wondered how the comfort, safety, and efficiency of a flight are influenced by the aircraft's design? Today we're delving into the realm of human factors in aircraft design. We're going to investigate the science of ergonomics, the importance of visibility, and the quest for comfort. We'll unravel the intricacies of cockpit layout and seating, and uncover how these factors shape the controls and, ultimately, pilot performance. Ready for a fascinating journey? Fasten your seatbelts, we're about to take off. What does ergonomics have to do with aircraft design? More than you might think. At its core, ergonomics refers to the scientific discipline concerned with understanding interactions between humans and other elements of a system. In the context of aviation, it's all about creating a harmonious relationship between the pilot, the crew, and the aircraft they operate. Picture the cockpit of an airplane. It's a space teeming with controls, displays, and instruments, all of which are meticulously arranged. This is no random configuration. Behind this layout is the science of ergonomics, ensuring that every element is placed in a manner that maximizes efficiency, comfort, and safety. From the height and angle of the pilot's seat to the positioning of the control panel, every detail matters. Ergonomics ensures that these elements are designed and arranged based on a deep understanding of human capabilities and limitations. It takes into account factors such as reach, strength, speed, and even stress levels to create an environment that supports the physical and psychological well-being of the pilot and crew. But it's not just about physical comfort. Ergonomics also plays a critical role in reducing cognitive load, preventing fatigue, and enhancing decision-making capabilities. By designing an environment that aligns with human needs and abilities, ergonomics helps to ensure that pilots can perform their duties effectively, even under challenging conditions. Ergonomics, therefore, forms the backbone of aircraft design, ensuring efficiency and safety. It's a testament to the power of human-centered design, where the end goal is to create a seamless, intuitive interaction between the pilot, the crew, and their flying machine. Visibility is not just about enjoying the view from the cockpit window. It's vital for safety and efficiency during flight operations. When we talk about visibility in aircraft design, we're talking about the ability of the pilot to see all the necessary visual references, both inside the cockpit and outside the aircraft. It's about ensuring that the pilot has a clear line of sight to the runway during takeoff and landing, to other aircraft while in the air, and to taxiways while on the ground. In the different phases of a flight, visibility plays a critical role. During takeoff and landing, the most critical phases of a flight, pilots rely heavily on visual cues. They need to see the runway's end, the horizon, and any potential obstacles. During the flight, visibility allows pilots to visually confirm their aircraft's position and orientation. It helps them spot other aircraft, weather phenomena, and landmarks. On the ground, visibility is crucial for taxiing, avoiding other ground traffic, and for identifying signs and markings. So how do aircraft designers ensure optimal visibility? They use complex calculations, simulations, and even physical mock-ups to determine the best shape and size for the cockpit windows. They also consider the pilot's eye position, the cockpit layout, and the flight operations to design the most efficient view. But it's not just about the windows. The arrangement of interior elements like displays, controls, and seats also impacts visibility. They need to be positioned so they don't obstruct the pilot's view. Good visibility, therefore, is not a luxury, but a necessity in aircraft design. Comfort during flights isn't just about luxury, it's a critical human factor in aircraft design. When we think of comfort in the skies, we often imagine reclining seats and in-flight entertainment. But there's so much more to it than meets the eye. Comfort in aircraft design extends beyond the passenger experience. It plays a crucial role in the well-being and performance of the crew, particularly during long-haul flights. Just like a well-oiled machine, a comfortable crew is a more efficient crew. Let's start with seating. Designing comfortable seats isn't just about padding and upholstery, it's a complex process that involves understanding human anatomy, physiology, and biomechanics. Seats are designed to provide adequate support, minimize physical stress, and reduce fatigue over extended periods. Next, we have temperature and humidity control. The human body is a wonderful thing, but it does prefer a certain range of temperature and humidity. Designers, therefore, strive to maintain an optimal cabin environment that is not too hot, not too cold, but just right. Noise reduction is another critical area. High noise levels can lead to increased stress and fatigue. Designers use a variety of methods from insulation materials to engine design to keep noise levels within acceptable limits. Lastly, there's cabin pressure. Maintaining a comfortable cabin pressure is vital, given the high altitudes at which aircraft operate. Cabin pressure regulation helps to prevent altitude sickness and ensures passengers and crew can breathe comfortably. Comfort, therefore, is key to minimizing fatigue and ensuring a pleasant flight experience. The cockpit is the command center of an aircraft. Its layout and control design play a crucial role in flight operations. Imagine a room filled with numerous buttons, switches, and screens. Now imagine having to navigate through these in a fast-paced, dynamic environment. That's what pilots do in the cockpit. The organization of these elements is not random. It's meticulously planned out to ensure maximum efficiency and safety. Think of the cockpit layout as a complex orchestra where each instrument has a specific place and purpose. The placement of controls and displays is based on their function and frequency of use. Primary flight controls, like the yoke and rudder pedals, are within immediate reach of the pilot. Systems that require frequent monitoring, such as the flight instruments and engine controls, are placed directly in front of the pilot. Less frequently used elements, like the fuel system controls or electrical switches, are positioned slightly out of reach, but still easily accessible. Now, let's talk about seating. It's not just about comfort, but also about reach and view. The pilot's seat is designed to allow easy access to all controls and a clear view of all displays. Adjustability is key here, accommodating pilots of different sizes and ensuring they can reach all necessary controls with ease. And what about all those colors? Did you know that they're not just there to make the cockpit look interesting? They serve a very important purpose, aiding in the quick identification of controls and displays. Color coding is used to indicate different systems. For example, engine controls might be red, navigation controls could be blue, and so on. This simple yet effective strategy helps pilots quickly identify and operate the correct controls, particularly in high-pressure situations. So the next time you see a cockpit, remember, it's not just a collection of buttons and switches. It's a carefully designed workspace aimed at reducing mental workload, increasing situational awareness, and enhancing decision-making capabilities of the pilots. A well-organized cockpit layout, therefore, enhances efficiency and safety. All these factors come together to significantly impact pilot performance. The blend of ergonomics, visibility, comfort, and the layout of the cockpit and its controls all play pivotal roles in shaping the performance of a pilot. Let's start with workload reduction. A well-designed cockpit eases the burden on pilots by logically grouping controls and displays, making them easily accessible and understandable. This streamlining of information and controls allows pilots to focus more on the task at hand, rather than spending precious seconds searching for the right switch or button. Then there's the enhancement of situational awareness. By providing a clear line of sight, efficient control layout, and comfortable seating, pilots are better able to understand and respond to their surroundings. This awareness is crucial, especially during critical phases of flight, such as takeoff and landing. Improved decision-making is another significant benefit. A cockpit that's designed with the pilot's physical and psychological well-being in mind helps reduce fatigue and stress. This, in turn, allows the pilot to make better, more informed decisions, especially in high-pressure situations. Comfort also plays a crucial role. Long hours in the air can be draining, and physical discomfort can be a significant distraction. An aircraft designed with comfortable seating, optimal temperature and humidity control, and effective noise reduction can significantly improve a pilot's stamina and focus. It's also worth noting that these factors are interlinked. For example, better ergonomics lead to less physical strain, which contributes to comfort, which then aids in maintaining situational awareness and making sound decisions. Similarly, improved visibility can reduce workload by making it easier to monitor the aircraft and its surroundings, which in turn aids in decision-making. In summary, the design of an aircraft has a profound impact on a pilot's performance. It's a complex, intricate balance, but when done right, it can significantly reduce workload, enhance situational awareness, and improve decision-making. Good design, therefore, leads to safer and more efficient flights. So that's our journey through the impact of human factors on aircraft design. We've navigated through the science of ergonomics, understanding how design choices can maximize efficiency and safety. We've looked into the importance of visibility, highlighting how it influences a pilot's ability to see crucial visual references. We've discussed comfort, recognizing the need for supportive seats, and the importance of temperature and humidity control, noise reduction, and cabin pressure. We've delved into the cockpit layout and controls, exploring how they're organized for efficiency and safety. And we've examined how all these factors collectively influence pilot performance, ultimately leading to safer and more efficient flights. The ultimate goal of good design, as we've seen, is to create an environment where the pilot and aircraft work together seamlessly. This synergy is what makes the magic of flight possible. Thanks for joining us on this enlightening journey. Until next time, keep exploring. Enjoyed our deep dive into aircraft design? Don't forget to like, share, and subscribe. We've got a lot more exciting content coming your way, so stay tuned. Safe travels and see you in the next video.